This is 3.5 day 1 part 2. I would recommend that you write down this example. You're going to see an example or a homework assignment problem like this. And we're giving you the formula in the oval. So write down that formula. And then I'll explain what that formula means. So the formula is A sub t, so that's your end amount. A naught is your initial amount. 0.5 means that there's a decay going on. It's decreasing over time. If that 0.5 was a 2, then that means it would be doubling over time. And then we're raising it to the t over k. And then the time that's going on over the half-life time. So I'll kind of help you guide you through this problem. You might see a problem like this in your science classes. They talk about half-life. Do they do that in science? Yeah. A little bit? Okay. So here's what we're given, a half-life question. The half-life of a radioactive radium, 226 Ra, is 1,620 years. So it takes 1,620 years for this radium to decrease by half its initial amount. And then we say, if we give you 20 grams of radium, there's a two-part question, how much will be left after 1,000 years? So I would recommend that you write all these pieces down, and then I'm going to help identify the different pieces and where they go in the formula. So the A sub t is very similar to like our word problem that we just did, the population problem. It's the end amount. Or if you think about compounding with money, it's the end amount. In a savings account, after you've saved it for 5 years, what would be the end amount after 5 years? A naught represents your initial amount, where you're starting at. Then 0.5 represents the half-life. We want it to split in half. Then the t is your time. And then your K is how long it takes for that material to decrease in half. So they'll give you that length of time. So in this problem, it is 1620. It takes 1,620 years for that radium to decrease in half. So now let's go out and find the other pieces. So we've identified one thing, 1620 is the K. How long it takes to decrease the radium in half. Pardon me? Yeah, where's the T at?
1,000.
Yeah. So after 1,000 years, we're trying to check and see how much radium is in the ground or wherever this is. Yep, and then the 20 is the A naught, the initial amount. So are we ready to go and substitute it into the formula now?
Yeah.
We have all the pieces? Okay. So the end amount is our unknown. Our initial amount is 20 grams. 0.5, or if you like the half, or if you like it in fraction form. And then we're going to raise it to the T over K. So 1,000 over 1620. So let's just kind of roughly guess. If we were at exactly half 1620, how many years is that?
Half of that?
Yep, half of 810 years.
Yeah.
So if we were at 810 years, how much should we have in radium? About 10. So our answer should be more than 10, but probably less than 15. So somewhere between the 10 and 15 grams. So now we would use our calculator. I tend to do the exponential first. And then I go back and multiply it to 20. Because PEMDAS says we do our exponents first, then we do our multiplication second. So I would say 0.5 raised to the 1,000 divided by 1620. And throw parentheses at the end in your calculator. And do you get approximately 0.65189? Okay. So I'm just going to write that down. Just so you're checking it. And then multiply to 20. Did you get 13.038 grams? So our guess was about right. We were somewhere between the 10 to 15 grams we should have had.
How many decimal points should I really give out?
I would say 3 significant digits. Okay, part B says if we have 4.5 grams after the half-life has been going on, 900 years, what was the initial quantity now? So go ahead and write this piece down. Where is our A naught at? We don't know it. That was our initial quantity, so that's our unknown. Where's our A sub T? 4.5, that's our end amount. What else do we know? Oh, T over K. T over K. What's our T? 900 years. And what's our K? 1620. It takes 1,620 years for it to decrease by half. So if my T was 1620, then I would be at half the amount. So now let's go ahead and enter in the pieces to that blue equation. So what will be the left side of the equation? 4.5. 4.5. Our initial amount? Unknown. 0.5 raised to the 900 divided by 1620. Now we're solving for A naught. So you may want to just do that right side exponential first. So you put 0.5, raising it to the 900 over 1620, and you get 0.68039. And then what would you do?
And then divide by that.
And then divide by that. Yep. So our initial quantity was about 6.614 grams of radium.
That would be the term.
Yep, that's the initial amount. That's what we started with 900 years ago.
It doesn't make sense.
It was a different problem, a different end amount.